All right, well, good morning everyone. Thank you very, very much for coming. So, my name's Matt Smith, so I'm one of the systems engineers here at Palo Alto Networks. I've been doing it for a lot longer than I would ever care to admit in front of anybody. And yeah, today what we're going to do is actually go through something we call an ultimate test drive, which is kind of a hands-on sandbox essentially, where you're given an environment, a bunch of scenarios, and essentially we're going to ask you to go through that work guide and actually kind of get a feel for how we do things. This is going to come as a surprise to absolutely nobody. So, if we look at everything nowadays, everything is going basically, IoT based. The whole perimeters kind of doesn't exist anymore. You've got users all over the shop, and the way we use technology has changed massively, even in the last kind of couple of years. Someone's mentioned cloud already, wherever that's public, Amazon, Azure or GCP or IBM's Bluemix or something like that, or just the convenience things of going down an Office 365 route, for example, rather than a traditional proper licensing model. And a lot of that has driven social change, and social change always pushes back against technology change. And we really now, in this day and age, have to be smarter about how we use technology, especially in security, and especially around things like credentials and decryption and application awareness and what people are actually using day to day. So this is something that we have to kind of consider, and technology is a way to make that more affordable and more easier to consume. So I'll start a bit of background about Palo Alto Networks and kind of where we came from and what we did. So going all the way back in time to around 2005, 2007, we had this concept of this firewall that would run at layer 7. So we all know layer 4, port and protocol. Been doing that way for a long, long time. Problems with port and protocol is applications are kind of really port agnostic nowadays. They don't really care. There's nothing that physically binds, say, FTP to port 21 anymore. When you look at a lot of the big breaches, Target was always the big one in the US. That was FTP over port 80, for example. And I've seen myself firsthand a very sophisticated attack in a university customer where the firewall was dropping every other DNS packet. And we couldn't figure out why, so we opened up a packet capture of one of these drop packets, and it looked like DNS, and it was a legitimate DNS query. However, the problem was at the end of that packet, there was a piece of malware running on a domain controller that was using DNS as a command and control mechanism. And it was using the spare space available in the packet for its C2 data. Now in a layer 4 environment, that would have just allowed that traffic to go through because it sees UDP 53, happy days, not going to question it at all. But because you're now application aware, you have an idea of what these applications look like and what the correct format should be and the syntax and the padding and everything else. The fire went, this doesn't look like DNS anymore. It's 99% of the way there, but because of this extra thing at the end, I'm not going to allow it to go through. And as a result, we were blocking the C2, and when we dug a bit deeper, it was actually uploading basically the contents of all the shared drives up out of the environment over DNS, which was really, really cool from a forensics viewpoint. So again, to kind of illustrate it, going all the way back, and a lot of organizations still look like this today. So you have your firewall, and then you will have kind of your additional services wrapped around it, more traditionally known nowadays as UTM. And these kind of products were kind of born out of necessity, because if you go back far enough, you would have had a dedicated AV box, you would have had a dedicated IPS box, and for the lucky few, a dedicated quality of service box and things like that. And it was all sandwiched down onto a UTM. And what they did was they literally took the software from these different boxes and ran them as serial processes. So what we mean by that is, as traffic enters that UTM, the layer 4 firewall module looks at it first and says yes or no. Then it moves into the AV module, waits for a response, then it goes into the IPS module, and perhaps a quality of service module, and a decryption module, and things like that. And that's why when you turn on features, the performance starts to drop through the floor. Because you're asking it to do more things in a serial manner. But we don't really think that works. And what's even more alarming is more recently, that design methodology has moved into a detect and remediate model, which is essentially saying, let's allow the attack to happen, let's allow you to get breached, and then we'll have a go at cleaning it up later on. Now, we don't think fundamentally that's the right way to do it. And that's why we went down this thing called the prevention model instead. It's actually very, very straightforward. It's very tough to execute, but it's very straightforward. And there's a couple of key things you have to remember. One is that visibility piece. You can't protect what you can't see. It's as simple as that. So whether that is having to enable things like SSL decryption, for example, because back even 5 years ago, maybe 20 to 40% of all web-bound traffic was encrypted. Nowadays it's 60, 70, 80%, depending on the organization and in the traffic mix. So actually that requirement to do decryption to suddenly start seeing what's inside that traffic, not only for the applications but the content within them, puts a massive performance demand on the firewalling infrastructure, so we have to be mindful of that. But once we have an idea of what it is we're trying to protect, if I go to an organization and say, how many SaaS applications are you using today? They will say, oh, we're using 4, maybe 5. We run an audit and we find they're probably running closer to 20, 30 or 40. And in those environments, we then can give them the ability to say, well, now you know what you have, now we can actually look to start reducing what we call our attack surface. So whether that is outright denying access to and from applications, based upon a user or a subnet or a zone or anything really, or even just basic stuff like doing quality of service, at an application level. And that becomes particularly relevant for gray, these applications that sit in the kind of that gray space, where we kind of go, well, we don't really want to block them, but we don't really want to allow them. So we'll just put a quality policy in to make it kind of unusable. And that's what universities and education customers do all the time. Now once we have that information, now we have an idea of what it is in our infrastructure and the things we have, and we want to protect them, and we've kind of done our due diligence and kind of cut off a lot of the attack vectors, let's obviously prevent known threats. If we know something is bad, let's stop it. It's fairly straightforward. But then we have the hardest task of them all, which is actually trying to take something that's unknown. Something that is potentially malicious, potentially not, figure out what it is, and then come back with a verdict as quickly as possible. Now, how many of you actually have a proper plan for when you're breached? 1, 2? Okay. Have you ever actually practiced it for real?
Once.
Once. How long ago?
About 6 months ago.
That's the right answer, well done. So, a lot of organizations, this may come as a surprise to you, but some big high street brands didn't actually have a plan. We said to them, you are breached. We have access to credit card data. What happens? When we don't know. Things like that. It's actually quite frightening. And a lot of the time when we see people do get breached and we see events happen, it was entirely preventable. Usually it's a configuration error, or usually it's a kind of an oddball scenario where, oh, we never thought this would happen, but lo and behold it did. And no matter how good your policy and your tech is, it's the soft fleshy thing between the chair and keyboard is always going to be the undoing of it. Right? So we have to kind of account for those fringe cases. And what's even really hard nowadays is actually trying to figure out if something benign, something that's got good piece of software, like say PowerShell, being used for malicious purposes. That's really, really difficult to do. Because when you think about it, the terms malicious, benign, and greyware, they're terms that we created to label things. Now, to a machine, it doesn't really care. It sees code and it'll execute it, and there will be an outcome of that. The outcome might be its undoing, but it doesn't care, right? It's got a function and a job to do. So we're actually trying to teach machines to label things as malicious, but for legitimate software is really, really difficult. And a good case in point is we recently stumbled across a piece of ransomware that was actually written entirely as a PowerShell script. That's really scary, because you can't actually blacklist it, because you blacklist PowerShell, you're going to have a very unhappy sysadmin team and a very unhappy help desk team. But at the same time, we can't allow it to happen because we have no way of controlling who is allowed to execute it. Okay, it's a very, very difficult scenario to be in. So that kind of led us to create this instead, this Evolution 2, as we call it. And this kind of really took what we were doing on the firewall and spread it out kind of laterally. So on the endpoint side, and it's something I'll show you an example of it in a moment, every kind of attack and breach that happens, there's always an endpoint involved somewhere. Okay, very rarely do you actually see an attack on infrastructure that doesn't involve an endpoint. By an endpoint, we mean it could be a workstation, or it could be a server, or it could be some resource running in the cloud. And actually what we're finding is when you look at a big breach like Equifax that happened, big insurance company in the US, 400 million odd records were leaked. including everything, social security numbers, finance details, personal addresses, basically anything PII. That was quite scary. What we actually found was they were running in AWS, and they had a golden image of a web server that was running Apache struts. Someone had a 0-day against Apache struts. And what was happening is as people were logging into Equifax, AWS had its load balancers set up, and it kept scaling up and scaling down. Every time a node was added, their problem just got worse and worse and worse and worse and worse. Because we don't know, we can't predict when that node may be shut down. So you have this period where it's alive and it's compromised and it's running, and it has effectively a complete backdoor into the infrastructure, and no one knows anything about it. And what we found was that they actually weren't running anything on their endpoint. That golden image, as it spun up, was running a completely vanilla Linux environment. There was no security whatsoever on it. In fact, if you poked around hard enough, SSH was open to the outside world. That's quite scary in itself. And what we found was that at the time that they were breached, they were actually benchmarking a couple of endpoint vendors in that environment to see the impact load it had on that VM. Because obviously, if you're running stuff in a public cloud, every compute cycle you consume costs you money at the end of the day. Every disk I/O you use costs you money. So they were trying to get something that was lightweight enough that wouldn't cost a fortune for them to start running. And as they were finding was they were putting these big, heavy AV suites on that as the machine span up, it wanted to scan the entire drive, it would throttle the hell out of the disk I/O, cost them a lot of money, and then it would shut down again. Okay, it's actually cost them something like 1.5 times with traditional AV suite. So there's something we have to consider there. And of course the cloud security piece we talked about, where if you're running resource in, from a compute standpoint in any of the public clouds, or if you're using storage in a public cloud environment, one of the things that catches a lot of people out is when you set up an Amazon S3 bucket for the first time, its default permissions is public sharing, which is really, really not great when you think about it. And a lot of people think, oh, it never happened to me, I'll make sure I've got that checked off. It happened to the United States Air Force. They've ran afoul of the exact same thing, so it can happen to anybody, and it does very frequently. And there are tools and utilities that you can get that actually scan the S3 address space to figure out what buckets are open and what ones are not. Okay? So you can actually use off-the-shelf utilities to start probing this information. And it's quite relevant, because for about $25, $30, I can buy access to an AWS account. Don't know who it is, I just have access to an AWS account. And I can use that for whatever purpose. And there have been stories, and we've seen a couple firsthand, where customers had their AWS account compromised, and the person who compromised it span up a load of Bitcoin mining VMs using the GPU-assisted instances, which are not cheap, I can tell you that much. They come back after a day, and they've got a bill from AWS for a couple $1 million. And Amazon just say, this is your problem. We can't tell if you were breached or this was legitimate. You used the compute time, you have to pay for it. Yeah. And for about $5, $10, I can buy stolen credentials. And those stolen credentials can actually be quite useful sometimes. For example, if I buy a set, the first thing I'll go and do is check, can I log into Office 365 with them? Because there's a very good chance that you're using, say, OneDrive, for example. And if I get the right type of user, like an IT administrator, I then potentially have access to everything. And what we have seen a lot of is people accessing commonly accessed files inside a shared storage medium like Dropbox or OneDrive, and then weaponizing those files. If you think about it, if you're an organization of even a couple hundred strong or a couple thousand strong, and that file is synced between hundreds or thousands of endpoints, and it's weaponized, my chance of actually successfully getting a beachhead in that environment dramatically increases. Yeah? So it's very, very scary stuff. And what we then do is we then feed this back in something called our Threat Intelligence Cloud, which if you've been working with us a while, you might have heard of it in another form called Wildfire, which is another piece of that puzzle now. And what we do is we actually share that intelligence across everything down at this green layer here. So if an endpoint finds something it doesn't like, that tells the cloud, which then tells the files, and also informs stuff running in the cloud, and vice versa. It happens all across the board. It happens in 5 minutes flat. Okay, no one else can get anywhere near to that. Okay, and I'll show you some stats and figures around it in a bit. But for now, let's move on slightly. There's a lot of stuff in here that no one really wants to know about. So I'll show you a couple of kind of key highlights to me that I think are quite interesting in today's world. So everyone here has got an Office 365 account, yeah? Or use something like that. Now, here's a really interesting problem for you. If I have a personal Office 365 account, what stops me logging into Office 365 from a corporate device? Absolutely nothing at all. And that's a bit of a challenge, because from a data leakage point of view, if I have a corporate device that is synced to my corporate OneDrive, for example, and a user logs into their personal account, they can just take all the data from the corporate device and move it up and out into their personal one. Okay? Fairly trivial thing to do. A lot of people do it. So what we can now do is actually use the firewall to some degree. So we can actually put this header in Flow. And this header basically instructs that SaaS application, and there is a list of supported ones as well, that basically says, if I'm going to Office 365, my @Palo Alto Networks account is perfectly fine to log in. Anything else, deny. So when I log in with my personal Outlook account, actually Office 365 turns around and says, sorry, no, you can't do that. And actually stops me logging in. So just a very simple control check like that solves a lot of problems immediately. Okay, just a little thing. It's a standard feature on all the firewalls. You just have to turn it on. Okay, there's a lot of that at the moment. What else was there that was interesting that I can share with you? I'll actually show you this. So this is where stuff gets interesting. So my background is all malware driven. Okay, used to work in the kind of threat world, and malware is my thing, taking apart how they work. And this is Wildfire under the hood. So for those who don't know, Wildfire is the all-encompassing name to the engine that we have that basically tries to turn unknown into known. And its job is very, very difficult because it has to look at a lot of different things. In fact, it looks at over 2,000 things nowadays. And every vendor has some permutation of their version of Wildfire to some degree. Here's a little fun fact for you. They all use the same off-the-shelf open source sandboxing software. And that has a bunch of problems because the malware writers have figured out, oh hey, this stuff actually exists, and this is what's being used to kill our attacks. So we had to go away and basically build our own hypervisor from the ground up, because you can't use something like KVM, for example, and actually start building in these checks. You have to mimic a real machine, and that's really hard to do. And then you have to start mimicking user behavior, which is even harder to do. Because there's malware now that will look at things like a certain number of keystrokes tapped in, or how many reboots, or how many, what's the tracking of the mouse looking like. And this is all stuff you can pull from Windows directly without any suspicious activity. So that's very, very difficult to try and figure out. Yeah, but there's this new stuff here. You see this thing called dynamic unpacking. And what a lot of the malware writers got quite alert to is when they build code and they deploy code, AV engines have got pretty good at scanning that at a glance and going, this looks like malware, this doesn't, based on certain characteristics. So what they do is actually try and obfuscate code. And if you want later on this afternoon, I can show you a write-up we did on something called Oil Rig, which is an attack campaign. And they used a couple of packing utilities to obfuscate code and basically try and hide it. And now we can actually unpack it. But we're the only vendor in the market to do this thing called bare metal analysis. So if the sandbox kicks out saying, hey, I don't like this, but it looks clean, but I think there's something here, that goes to a real human with a real machine. Okay? It's something microscopic, like every 1 in a million samples goes to a human. But some of the really interesting attacks we've found have come out of bare metal analysis, where people have actually now started to write code that will sit dormant for, say, 6 months to a year. Just does absolutely nothing. It's not interested in that. And then one day it will just randomly spring into life. And it could be based on any number of triggers. So there's a lot of interesting stuff happening there. Now, one thing I did mention was, say, we've just been through that. Everything kind of revolves around an endpoint. Every attack, and later on this afternoon, in a bit, we'll be plugging this little guy in and showing how endpoint security can be really blown open. And we found that if you have traditional AV suites, the general consensus is they don't really work anymore. The threats are evolving too quickly. If you're relying on signatures, you can never be up to date quick enough to start preventing known stuff all the time. Then you get kind of this new market, this Nextgen Av market, and it's all essentially based off machine learning derived algorithms and things like that. It sounds really glossy, really fancy on paper. The reality is actually, they're not that effective. When you do testing, they're not, generally speaking, not doing that well. The reason being is they're all trained on very specific data sets, which say this is malware, this is not. So when it encounters something new and unknown for the first time, something that skirts the boundaries of both, it kind of freaks out and goes, we don't know what to do. So either you end up with two possibilities, lots of false positives or no protection. It's a trade-off you have to make. And then you get into EDR. Concept's great, execution not so great. A lot of people rely on it for their primary method of defense. And these are the people who get breached quite often and can't figure out possibly why. So we need to kind of figure out how we build that in. So again, how can we turn the platform to this situation? Well, like everything, you have to approach it from a different view. As we did with the firewall all those years ago, you have to look at what are the problems people face today and how do we go about resolving it? How do we get as close to the source of the problem as possible? Well, actually, it's a different method entirely. You actually have to go after something called the techniques. Now, if you look at AV vendors and endpoint security vendors, they rely on traditionally signatures. And these signatures say, this file is bad, or this file belongs to this family of malware, don't execute it. Then you get host-based IPS type technology that basically says, oh, Adobe Reader has got this vulnerability in it, we have a signature to stop that vulnerability from running, which sounds kind of great. Problem is again, it relies on signatures. And then you get back to the next-gen guys, where they say, oh, we'll train on algorithms, blah, 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 blah. The reality is that actually they don't have enough information to work with. So you can't get a fair analysis of the market, as it were, and what's actually out there running in the wild. But one thing that no one's thought of yet is actually going after the techniques. So on the Windows platform, there's about 25, 30 or so techniques. And regardless of if you're running an exploit or a piece of malware, you have to use these techniques. Okay, this is a constant thing. Every year there's actually maybe only 2 or 3 techniques that get developed. And these are things that would kind of, you'd put into the big bucket, things like Spectre and Meltdown, those types of things, yeah? So the idea is I have a document, let's just say it's this PDF document, to keep it simple. We have a vulnerable version of, say, Adobe Reader. Now, what happens is the user opens that document and it immediately crashes. That's a good sign that this is actually probably malicious, okay? Because it's not actually intending to do anything legitimate. What's just happened in the background is it's executed a series of techniques. Okay, so in this case, a heap spray and a ROT-based attack, okay, which basically maps out system memory and then corrupts it. Then it utilizes an operating system function to pull down the big, heavy-hitting secondary malware payload. Could be anything you want. Okay. Now, in a host-based IPS model, it's looking at Adobe Reader and saying, is it vulnerable, yes or no? Okay, which doesn't really work, because software moves at a rate that is impossible really to keep pace with these days. And there's no point looking at it from a malware point of view because we have never seen this file before. No one on the planet has seen it before. So we're kind of flying blind anyway. But if we look at the technique-driven approach, we actually don't care if the software is vulnerable. We don't care if the file is malicious. When we actually execute it, that's when we step in and say, well, hang on a minute, why is it trying to do a heap spray? That's a bit weird. So we're actually going to stop that from running. Same is true for Mac OS and Linux environments as well. And the great thing about this is, because you can't just use one technique, you have to use multiple to actually get what you want. Even if there is a brand new technique we've never seen before, we actually have a very good chance of actually stopping it having never seen it before. And it's something that we will also do as well. So in kind of real world terms, what does this actually mean? So every year, thousands upon thousands of vulnerabilities. If they're particularly bad, they get CVE numbers and things like that. And people solve that with patching. In our view, if it's a critical patch, you have 24 hours. Even then, that's being generous. If it's high, you reckon 72 hours, and it's medium, kind of up to a week. And then regular cycles after that. But again, people and patching and software that doesn't play nice with centralized patching utilities is just a nightmare, right, from any Windows administrator. And in all of those thousands of vulnerabilities, you'll see that a good fair chunk of them, maybe 60-odd%, will actually be turned into exploit code. Okay, so we'll have some server software or some endpoint software or some Office suite or whatever that we can actually now weaponize a piece of code to go and take advantage of that vulnerability. Okay? And then signatures and behaviors kind of trying to figure that out. But because again you're going after techniques where there's actually a very few number of them being developed every year, actually we're a lot more effective. Everything above that is kind of irrelevant now. Yeah? And because we're back to that power of the platform piece, if my endpoint finds something it doesn't like, that will inform Wildfire, so Wildfire can grab that file for a secondary state of analysis, which we can then inform the firewalls with, which we can then inform things running in the cloud with it, whether it be, Aperture looking at SaaS applications, indexing what you've got in the contents of your file storage or anything like that, and saying, well, hang on a minute, there's an endpoint that's just executed this file, and you have it sat in your OneDrive account. That's bad. Let's go remove it from your OneDrive account to stop it synchronizing to other machines and things like that. And again, as we spoke about, buying access to an environment really, really cheap. And if I can get a successful piece of ransomware in that environment, my $5 investment can quickly become hundreds or thousands of dollars return. You don't need to be good at maths or business to figure out that's a pretty damn good deal, right? So again, as you kind of look at it, what do we have to solve these problems? Because it is a security risk. Well, native security. Again, these guys are in the business of selling a service. They don't really care about the stuff you put in it. Okay? If you want to put malware in it, fine, knock yourself out. Things like Dropbox is probably the largest distribution platform for malware on the planet because you can create an account free of charge. You can credit with fake email addresses. You don't have to put credit cards in, so it's practically untraceable. And I can use it as a basic command and control server. Brilliant. You've got a lot of these what we call CASB vendors, or cloud access security vendors. And their basic stance is you need to push all your traffic through us, which is typically a proxy. And proxies are nasty, hateful things, as we all know, to get access to OneDrive. Problem is, it appears to me that these guys have never heard of these things called mobile phones or, uncontrolled non-corporate devices. Because what's stopping me going and accessing my corporate 365 account from my home PC? Nothing. Okay, they can't do anything about that. And then you get kind of the legacy stuff, which is not really worth talking about. So when it comes to SaaS apps, and this is all out of order for some reason.
You can remove access on 365, can't you?
You can, but not as much. And plus, it doesn't help for other stuff as well. So you have things like Dropbox, for example, or any of these guys. You're really at the mercy of that particular application, that vendor, right? Because it is very, very difficult. How would I, say, restrict access to AWS for users originating from a non-corporate device? It's really hard to do stuff like that. So actually what we do is we approach it from the other end of the spectrum. Rather than force traffic through something, because you've already made the investment in a fancy firewall, which can sit wherever you want, whether it be on-prem, in a data center, a shared DC, or in the cloud, or wherever you want, use that investment to shunt traffic through it, and at the same time have something running in the cloud that actually uses the API backend to talk to the SaaS apps. So regardless of how you connect to it, because there'll always be scenarios where people connect to stuff and not go through your fancy firewall. Okay, it's just a reality of life. We still need something to look at what they're doing. Okay, because if I'm going to access, say, a box from my personal machine at home, and I'm not going to go through any kind of network security, well, I could upload a piece of malware to it, and it would be completely invisible to the firewalls. So I still need something to kind of inspect what we're doing, okay, and actually try and take action. So kind of coming back then, that was kind of SaaS. So how do we start looking at how to secure compute workloads? Okay, because a lot of people now, as yourselves, say, moving or building stuff from scratch in Azure because it all sounds great. I don't have to worry about, big heavy iron anymore, running infrastructure and dealing with vendors on RMA replacements when stuff inevitably fails and things like that. Well, actually, again, people rely on that basic level of security that these guys provide, and it's the same story. The stuff you put in is your problem, not theirs. Well, the key thing is that the same software that runs on your nice blue bit of hardware on-premise is exactly the same as it runs in the cloud. Okay, so all the same features, all the same functionality is all the same. Okay, so if you want to create a policy that for SaaS apps, you can do exactly that. We have organizations who don't run any physical firewalls, they run it all as virtual machines, and they put them all into AWS and Azure and things like that, and use the load balancing capabilities to scale it out if they need more compute capacity. So suddenly, rather than them running, buying a, say, a 3 or 5 year contract and then hitting a brick wall saying, well, we've now run out of compute capacity, we need to go buy more, what they do is they just put it in the public cloud and just keep scaling out as they need it to. Okay, it's a very, very nice, elegant way of doing it. But obviously, the big thing with public cloud is automation. No one wants to do things by hand anymore. You want to set it up once, template it, and then keep going with it from there. And that's really hard to do because a lot of people take existing stuff and don't re-engineer it to work in that way. Well, the good news is security has always been seen as that blocker to that. I've got to wait for the security teams to put rules in, blah, blah, blah. Well, actually, no, you don't need to do that anymore. So you have the frameworks, things like Ansible, Terraform. There's a couple of others floating around, like Salt, Chef, Puppet, all the other ones, to actually kind of integrate into your existing workflows. And I've seen now examples of organizations that will have like a Terraform template that will actually spin up, say, a CloudFormation template in AWS, and I can't remember what the Azure version is. And it has a VM series firewall in it, has all the apps in it, has all the compute instances to build it, and it runs and it deploys in 10 minutes. Okay, really, really simple stuff. Really easy to do, in fact. And then on the same side of it, you can actually now go and interrogate those cloud vendors to say, hey, what stuff do I have running in here? So if I have 1,000 virtual machines, I don't really want to be creating 1,000 address objects or throwing open a policy for the subnet, because that could be a bit dangerous. So actually now what you can do is actually go to that cloud vendor and pick and basically tell it, give me the IP addresses of these 1,000 machines that match this criteria. So I might have a tag that says this is a web VM, this is a database VM, this is an application VM. And then based on that detail, I could then write a policy that says, oh, if it's a web server, it can talk to the database servers over these apps, these ports, and this security profile on it. Okay, so if I create a new VM and it adds itself to that database group, I don't need to change the policy. I've configured it once and left it alone. Okay, we let the automation layer take over and actually do everything on its own, which is pretty neat because, again, I'm a big advocate of saving time where possible. So this is how we see the model. It's a very, very simple model. It looks complicated, but it's actually very simple. For anything on the network layer, so as we call it, the inline security in the public cloud, that's where the VM series steps in, or the virtual firewall steps in. Okay, because again, the same software that runs the on-premise devices, the big blue bits of tin, runs in a VM. You can stick it in any public cloud you want, and it works in the exact same way. We got a bunch of reference guides published, and a bunch of different architectures published. That's all available. It says if you've got this kind of deployment, you want to do this. If you want to go down this deployment model, you kind of need to do that. Then the other side of the coin is, again, as we talk about securing the application workload itself. So I have stuff running in, say, Amazon or Azure or GCP. It's still software, it's still vulnerable. Okay, whether it's containerized or not, it's still potentially vulnerable. So what we need to do is then secure that endpoint with something like traps. And then actually, this is where it gets really interesting. The platform as a service piece is the guys have now taken to calling it. So when you go to an Amazon or an Azure, you can consume storage and compute. That was historically all they did. Whereas now today, you've got load balancing, you've got databasing services, you've got caching engines, you've got absolutely everything. Amazon's got something like 2,000 or so unique services that they can provide you as part of AWS, and Azure is up to like 1,000 or something now. Okay, and GCP is not far behind it. So who's actually auditing how that infrastructure is being used? Who's actually looking at it and saying, well, we're consuming Amazon RDS. How is it being configured? How is it being used? Okay, are we using it securely or are we using it insecurely? And if you go and get yourself spin up yourself an Amazon account, we have a thing called Evident, which looks at all this, and we've just acquired another company called Redlock that does the exact same thing. If you spin up an AWS account, hook Evident up to it, it'll only pass something like 40% on Amazon's own best practice checks. So right out of the gate, you're kind of on the back foot. So who's actually auditing that environment to say, hey, what's going on? And one of the big high street banks is a big Evident customer of ours, and they were absolutely terrified of a compute instance spinning up that had a public IP address, because that was potentially a backdoor into the infrastructure for them. And when your business is finance and banking and everything else, that's not something you're kind of going to be keeping staying up at night about. So they ran Evident, and in their world, the only things that should have public IP addresses are load balancers. Okay, then it hits a firewalling layer, Then it goes through another load balancer that then hits the actual EC2 instances. So they had about 14,000 virtual machines running inside AWS at any one time. How many of those 14,000 do you think had public IP addresses? About 11.5. Actually, it turns out the bulk of their infrastructure was sat outside the load balancers, which is why they're wondering they get such poor performance out of their web apps. And all the apps they had for customers on phones and things. And yeah, basically they had full-on panic stations because it turns out that even though they made the investment into all the VM series, they weren't seeing much traffic because it was all being bypassed and going straight in. And so naturally they were very displeased with their DevOps team. And in the course of the next 3 months, they completely re-architected it. So they went from about 11,500 VMs of public IPs to about a couple hundred that were all on top of load balancers. And it actually solved them a lot of problems. And also saved them from having a really nasty breach as well. You know, and just to kind of go, you know, show you the timeline of events and things that have happened. All the back in 2013, public cloud was kind of like a very nice to have. People were saying, oh, it'll never happen, it will never take off. And actually, as you kind of go through all the way up to today, you know, Google Cloud came on board this year due to a lot of customer demand. But you can see we're starting to get more deeper involved in there. So whether it's, you know, things like the Azure Security Center, for example, you know, there's now a native integration into that. So you can start pulling stats and statistics out, and you know, then even automating stuff back into the firewalling layer to say, hey, you know, bad things are happening, do something here. Okay, very, very interesting stuff. So where does that kind of bring us today? Well, actually, I'll show you this first because this is quite interesting. So, you know, speaking of endpoint in public cloud, this was kind of, again, we need to adapt it slightly. But it was this year in January, the Korean CERT team, so kind of like the South Korean equivalent of GCHQ. They published a paper saying, hey, we found a zero-day vulnerability in Adobe Flash. Now, responsible disclosure is 90 days notice to the vendor. Okay, then you go public. So about a week later, Adobe released a patch, and then after that date, you know, patch is applied by a user. Now, that's kind of 50-50 gamble. You know, does the patch actually work? Is always a concern. How do I get it deployed? Is also another concern, especially for Adobe products. Now, between the announcement date and the patch date, if you're running a traditional AV suite, it's probably not going to stop any attack based upon that. You know, network-based IPS devices, such as ourselves, might have a fair chance at it, but again, it's 50-50 gamble. Now, what was really interesting is, a month prior in December, we actually saw a development version of said attack be blocked in the Wildfire traps. So someone, somewhere on the planet, was targeted by this attack campaign to figure out if it would work or not. Now, unfortunately for them, the people they picked was a Palo Networks customer, so for a whole month, we'd known about it and could, you know, put the proper preventions in place. Turns out it was only 5 minutes. Now, just for a laugh, we threw it against one of the earliest versions of traps we had that was compiled, version 2.3.6, that was built all the way back in 2014, just to see what would happen, and lo and behold, it stops it. Okay, so it stopped a 0-day that was just under 4 years old, that it had never seen before. Okay, again, that comes back to that technique-driven approach. If you'd rely on signatures and everything else, you'd have been kind of going, we don't really know what's going to happen. Let's just kind of see. And A/B testing is really, really hard. I'll tell you that much. So where does that bring us today? It brings us to this. So this thing called Evolution 3, as we call it. And it's kind of an it is an evolution in itself, and it's kind of the next big thing in our world. And you know, we came to the realization a couple of years ago that we, as a technology vendor, can never be the best at everything. Okay, it's impossible. You know, we're never going to do email security, for example. It's just too big of a challenge. We're never going to do full-fat DLP because it's just too big of a challenge. You know, and plus, there are much better vendors in that space who do that. So why would you kind of go and disrupt that market for no reason? Everyone's been to like an InfoSec or an IP Expo show before, yeah? Yeah. So every year when you go, there's always this very small little alleyway of about 30 or so startup vendors. And some of them have really grand ideas, you know, really great bits of kit, you know, a new way of thinking, a new way of solving a problem. Problem is in security, it's very, very hard to get your foot in the door. Very hard to become established and, you know, get customers on board because it is, you know, security, and people are very, very terrified of what if it doesn't work. And you come back the second year, and of that 30, there might be 10 left. The other 20 have been bought out or gone under. And by year 3, there might be 1 of them left. Okay. And we kind of decided, well, what can we do about that? Because it's very, very difficult for us as a vendor, as I said, to do everything to the standard that we want it to do. And the only way you're actually going to do that is by partnering with other technology vendors to solve this problem. And this is where there's something called the application framework now comes in. So what we do is we take all the logs from the firewalls, the endpoints, and stuff running in the cloud, put it inside our data centers, and then we make that available as an API to the outside world, which I'll show you in a bit more detail how it works in a second by doing this. And what it becomes, as I said, everything in green is now the sensor and enforcement points, firewalls, endpoints, Aperture, Evident, etc. We take that data, and we basically run it through or convert it into a common language that all these vendors must speak called the framework. And what that means is we can now have our first-party apps. So, Magnify, which is our behavior analytics platform. Autofocus is our kind of threat intelligence viewfinder. And then MyMail's for, you actually use it in the lab, so I won't talk about it. But then you can also start plugging third-party apps into this, so other technology vendors. So if someone comes along and builds a better analytics platform in Palo Alto Networks, you can plug it in. Okay? We don't really care. We want it to be open. We want people to do better. Okay? And then, of course, you can build your own apps as well if you want to. Okay? And people are building all sorts of weird and wonderful things to work with a framework. So before we dive into labs and demos and things like that, I'll wrap it up with this. So kind of what are the tools and things that you can do to kind of audit your environment, figure out what we're doing. So day one, we have this thing called an SLR, or a Security Lifecycle Review. What it does is we give you a demo box, or it could be a VM, doesn't matter, that looks at traffic for 2 weeks to a month. Okay? It then takes that data, turns it into a bunch of analytics, so it anonymizes it, and it spits back this lovely report that tells you, here is your network in a PDF. Here's all the apps we saw, here's all the threats, here's all the URLs visited, here's absolutely everything you'd ever want to know. So you use that day one to figure out that visibility piece. What do I have running in my infrastructure? And then day 30, day 60, day 90, day 120, etc., etc. You would use it to kind of gauge how your environment is changing over time. Because user trends and things like that happen. So for example, every time Apple releases an iOS update, my phone doesn't stop ringing and I can't update it. Because users keep ringing up saying, how do I write a quality of service policy to stop users obliterating my WAN connection? Okay? Well, it's easy. It takes you 2 minutes, in fact, to do it. But you need that visibility in the first place. But let's say you've deployed. You've bought the tech, you've deployed it. You typically most people deploy and just take their existing policy and convert it as is. Well, that's kind of okay to get yourself up and running. But really, you want to be going at full layer 7, full user awareness everywhere, right? Well, we have this thing called the best practice analysis. And again, everything's all free of charge you're about to see. And what this does is it takes your config and evaluates it against our best practice as us as a vendor. And when we deploy stuff as a vendor, we have to strive for a minimum of 92% compliance against our own best practice. It's impossible to get 100%. I can tell you that because I wrote some of the code that runs this thing. But the general consensus is, anywhere from 85 to 95%, you're generally in the ballpark we want you to be in. But it will actually trend it over time. So if you upload a second config file, it will then say, oh, you improved 10% over the last one. And here's where you improved, here's where you regressed. Okay? And it's a great way of actually keeping tabs on, especially when new features come out. Every year we launch a brand new version of code. And every year we add 30, 40, 50 odd new features. So if you upgrade and don't turn any of this stuff on, or the building blocks to it have changed, this is a great way to keep tabs on that. At the same time, there is this thing called the Prevention Posture Assessment. And what this does is this kind of a questionnaire, really. It's a self-evaluation of where you think you are in your cybersecurity stance. Okay, whether or not you're doing really well on endpoint, doing really, really badly on networking, doing really, really badly in the cloud, things like that. It's a great way to kind of just analyze where you are today. Okay. And then finally, we have this thing called Expedition. And Expedition is our name for our migration tool. Again, we can pretty much take any config from any of the big name vendors and kind of convert it up into our language. Okay? And the idea is, between this version and the old version, is this is designed to be left turned on. Because what it will do is it will actually analyze the traffic going through that firewall and say, oh hey, you've got a policy, perhaps a policy where any application is allowed, and it will say, oh, I've seen these app IDs hit this policy, do you want to add them to the rule? Okay, so I can start locking stuff down and start automating my approach to going full layer 7 and full user awareness everywhere. Really, really neat stuff. And then, so finally, if you think you're brave enough, we have this thing called a cyber range as well. So the challenge I always find with security is there's a lot of people who don't understand how it works in a breach scenario. Technology is wonderful, but not many people actually use it in anger. And I think really the only way people really learn is when stuff breaks. Yeah. And I was actually one of the architects behind this, so this is going to be interesting. No one in the company has successfully passed the foundation course with flying colours. That's how tough it is on foundation. What essentially happens is it's red team versus blue team. You're the blue team, we're the red team. So we give you an environment and you have to stop us from breaking into it. And no one successfully has passed it yet in the whole company. So it's a very, very fun day. It's in Amsterdam as well. There will be a remote version coming at some point in the future. And we say, if you get the opportunity, do go along to it because it is a great day out. Okay, you get given an environment that you've never seen before, and basically we start with a bunch of very small attacks and start ramping up the difficulty. And at the end of the day, we just do a Hail Mary, where we just send all the attacks in a randomized order and say, good luck while we go outside for a coffee. Then we come back in an hour and see people crying and going, well, why is it not working? And stuff's gone wrong and my environment's all broken. Good times, essentially. It's all good fun.